Okay, we're going to use the graph shown to answer directions and write the domain of the function as an inequality using set notation and interval notation. What do you think? What would our inequality notation look like? Less than?
And greater than?
So kind of like this? All right, then?
Infinity, or negative infinity and positive infinity.
So Bryce makes this kind of suggestion, is that right? Yeah, I think that's it, right? And next, so that's going to be our inequality notation. What would be a set notation? Yeah, so you could write x such that x is element of all real numbers, right? Is there another way you could do set notation? Yeah, there is. Which is x such that okay, so both of these are actually in set notation. And to me, I think this second way might be a little easier, because then all you have to do is take this thing right here and just plunk it right down there, okay? And then in interval notation, what does that look like? Okay, it'll be negative infinity, comma, infinity. All right? No, not too difficult, right?
No.
Okay. Let's go on to this next one here. Same graph, but now write the range of the function as an inequality using set notation and interval notation.
Would be, negative 2 is less than or equal to x is less than or equal to,
So you said negative 2
yeah,
is less than or equal to x,
yeah.
which is less than or equal to infinity, that one. What do you think?
Wait, wouldn't it be equal to
Or, yeah, no, it's supposed to be the regular, like, no, it can be equal to.
Oh, if you need infinity. So Gabby, that's what you said? Yeah, thanks. So is that going to be it? It's not it.
y?
That's not, it says y, right?
Yeah.
So let's go ahead and fix that y. So now is that right?
Yes, no,
No.
0 instead of negative 2.
Okay, so pay,
Oh, yeah.
so Connor says this would be 0 over here, is that right?
Yes.
Yeah, now it's right, okay? Now it's right, okay? Good. Now, set notation, y, such that y is greater than or equal to 0, right? Okay. And then interval notation, what is that going to look like? Bracket, 0, okay, comma,
Infinity.
infinity parentheses. Okay, so there we are. All right. Any other questions or observations on these? Okay. And to me, it's just like, to me, the one that would give me the most trouble if I was taking the test would be this one right here. But if I can think square-headedly about this thing up here, I could just, in fact, if you wanted to, you could just plunk this thing down here instead, couldn't you? Yeah, you could just put this in here instead, and that'd still be good, all right? So let's look at the next one here. Okay, now describe the end behavior of that function.
Maybe as approaches.
As x, we just arrow, is that right, Gabby?
Yes.
Okay, infinity, f of x approaches infinity. Okay. Any questions about that? Does that look good so far? Okay, and any other end behavior going on here? So as x approaches negative infinity, f of x approaches
Zero. No, 0.
okay, we're going all the way this way. As x approaches negative infinity, what happens to f of x?
Versus infinity.
Approaches infinity. Okay. Now this is a deal where you're starting high and ending high, right? So as x approaches infinity, right? As x approaches negative infinity, f of x approaches infinity. So it's like touchdown. Okay. Questions on that one? Okay. Next one. Now, what is the range of the function if its domain is restricted to -5 to 1 here? So just look at that and just think about that for a minute. You might want to make notes of the graph or something of that while you do that. Okay. What do you think the range is of this thing here if we restrict the domain? What is our range going to be for this thing?
Are we doing what notation?
I want to do interval notation, and that's a good question because what I'm assuming is we were given this interval notation here. So my assumption would be that we would answer in like language, right? Okay, well that's actually a good question.
So would it be brackets 2,
Okay, bracket 2, comma 4. Does that look right? That's what Gabby said, right? Is Gabby right about this? What do you think?
It's still just 0 to 5? Or wait, oh wait, it'll be -5 to infinity? I'm confused.
So, see, I'm looking at Bryce, and Bryce is just like, he's like, his eyebrows is crunched
I
down.
don't think it's right, but I don't know what.
Okay, see, that's it then. So that's the critical look. See, that's the look of a thinker. Well, we have any other thinkers weighing in? Connor's thinking, yeah, Gabe, what's your think?
I'm confused, very.
Any of you others? Thinkers? Marcus, you're a thinker. What do you think of this one? Riley? Riley? Good. Addie, you got ideas here? Okay, here now, okay, I'm just gonna weigh out something here. There's something that's not right about this.
Gabby.
Hey, I'm still walking through one out
Negative
first.
5, 1. Right out, like, that's not on the line at all.
So would it be 0?
Okay, so are you changing your answer, Gabby? Is that what you're doing?
I don't know. Sure.
I say we go with Gabby's answer because it's the only answer we have in the room.
Wait, so would it be 0 4 then?
Okay, let's try.
Because that's the lowest,
Yeah.
It'd be 4. Why would the 4 even be there?
because of the -5.
So
Well, I don't
what
know.
happens is, yeah, this is gonna be 0 here, and let's figure out why.
It's gonna be,
Okay, when we think about it, right, our domain is starting right here, right? It's going from -5 to 1. And so definitely you're looking at 2 to 4, right?
oh no, it's 4.
Except, because that's 4 right here, right?
Yeah.
But why is it going to be 0 instead?
Because that's the lowest one.
Yeah, because in this interval, I'm just going to box in everything, right? If you box in everything here and look at the y, so you got to look at the y values, not just between here and here. You got to look for the y values everywhere in that interval, okay? So that's why this is going to be our range, okay? Just watch out for stuff like that. And then we're going to, tomorrow, we're going to have pretty much, even though the morning periods are going to be shortened, we're going to have pretty much all the time. We're going to work on more on stuff like this, all right? So that is it for today.